Now we have to see about the binary tree traversal and tree iterators. In this traversing, a binary tree is usually work in recursively manner. This is the first approach towards approaching the binary tree problem. However, the recursive functions can be lead means to the it can be work in a large memory footprint, and often it till the time whatever we need to what the progress means, it will be give the instruction for the iterative traversal. When the traversing a tree iteratively, it commonly used in stack and queue operation. So with the common path of the stack and the queue can determine to use this operation to store the node where we need to visit. So we already know about the stack means it refers as a lost in first out, and queue is refers as a first in first out process. So while our stack and queue is not null means to retrieve the node from when we retrieve a node to visit, or how to put it the child node for that is a problem to have to uh, give to push the data element into the child node from the root. So by this process, we have to use the traversal iterator in binary tree method. Here, this is one of the pre-order traversal approach. It will be used to recursive manner. So first, the pre-order traversal means what? This is also already we have to see in binary tree traversal. Traversal means whatever the node of the element can be traversed or visit each node from left, right, or root. Okay. So under the pre-order traversal, first the process of the node to have visit first in root node, then it will be visit on left child node. After it will be visit on right child node. So the visit of the traversing node are root, left, and right. Okay. So in this progress, the recursive approach can use for recursively on root node, then after it will be pushed on left or right. For that purpose, we have to use the recursive approach. So here under the tree node, we have to check the node is equal to null or not. If the node is null means the process of the node of element can be put it in the root node. Then after one by one, the node will be stored in the left element and right element onwards. See here, there are the several approaches we have to use in the iterative manner. So first we have the node, we have to push on all the left node to stack starting from the root means in the constructor, we have to push the node in descending order. So in the as next of function, it can return true if the stack has an element. Otherwise, if it is empty. In the next of function, the pop the node from the stack, the element can be pushed into the stack, the right subtree of the node and return the value. So in the iterative traversal, we have to use next of function and has next of function. In iterating over the tree structure, this is a linear structure. We can start from one end to stop at another end. So we have to implement the iterative over the linear structure by using list or vector. Then how we can implement in iterative over the non-linear structure means we have to use tree. Okay, so that's why we have to use the tree traversal, such as the tree traversal of pre-order, in-order, and post-order method. We have to implement logically in iterator. Okay, so that we have to move over the element in tree in this same order. So under the tree traversal, we can already on the last slide we discussed about to implement recursively manner. So the tree has been processed until every node in the tree, it will process and carried out each of the element when it doesn't return anything. So in other hand, the iterative or non-recursive means the client code call a function, the iterator by one element and then returns immediately. In recursion, the inner functionality, how it will be used means we have to consider how the recursion is implemented. So based on that parameter value and local variables on stack, we have to use the binary search tree traversal to reference on the current node. It is passed as an argument to recursive function and built upon the stack as calls go deeper down to the tree. So the top of the runtime stack contains a reference to the current node and the element under it for the history required to backtrack up the tree to find the next node in the particular ordering. For adding the iterator means already we have seen as next of function and next of function. This is a one of the method we have to implement for iterator for adding the element in the for the linked list. So by this purpose, we can declare first in binary search tree class to implement the iterable interface and add the inner class for declaration for iterator within the binary search tree declaration. An iterator will store a pointer to the tree node. The next of function method is a dereference it to return the data element in the within the node. So by this implement of has next of function and the next of function method, we have to use the supplying method of a binary search tree class as an iterator of function. So there is a no case to iterator based on insertion function in binary search tree means, but there may be the case for iterator based for in deletion function. So in the iterator increment logic, we have to first start on the A node, then it will be visit on B and it will be visit on C. Okay, based on that in order traversal root left and right. So based on that, A is a root and B is a left node and C is the right node. So the pattern implement in the linked list, the iterator, based on that iterator, the next of function will be used for iterator step forward or backward within the binary search tree. So based on that pre-order, the traversal can be made on root left and right. Then how it will be involved root left and right node means based on the iterator function, the data will be pushed into the stack by using the next of or has next of function. So based on that, the traversal can be moved and push the data into the each child subtree. Then the pattern is reasonably straightforward, but how it can be moved up from the node for parent within the binary search tree means it is one of the iteration. So implement in non-recursive manner. So first we have for the function call of pre-order, and under the pre-order we have to visit the root left and right. So with the condition check, the current of the element is equal to null. If it is null means it return root of the statement. Then after the traversal can be moved on left and right. Then so the based on the same thing, we have to traversal on in order and post order. So by using the next of function, we have to visit the parent node, then the next node in the immediate left child. If it is already visit the left child means the next node immediately right child, it can be visited. Okay, so based on that next node, the pre-order traversal sitting a particular node in the tree. So it will be pop the current node from the stack, then push it the left or right children if they exist. Then, so under the next of function, how it will be involved. So based on seen before the system, the pre-order traversal, it is a simple task based on the C++. The task for pre-order traversal, when it is visited root means, then after left and right child will be visit and enter the data. If by using this next of function, how it will be involved based on that iterator means the same time side type, the node stack has been empty or not. First we check, then after the node check dot pop off, because the top of the stack pointer should be null means that then why the then after we have to enter the data into right or left. Okay, so for that purpose, recursively the node stack of the point should be in pop-up for each iteration. So if the current not equal to right child not equal to null means the stack can be pushed the data into right side. Otherwise, if the left can be not equal to null means the node of the stack pushed into the left child. So this is the one of the next of function. by using iterator in binary traversal. So by this is one of the example. So the top of the element is popped up initially, then we have to construct the element as 5. So the root node has been denoted as 5. Then next of the function, we have to insert two value 3 and 10. So 3 and 10 means first it denotes the element. Basically the binary tree means under the root node, based on the root node, if it is less than means it comes under left side, greater than means it comes under right side. So the 3 and 10, so 3 is less than 5 and 10 is greater than 5. So it push it into the left and it will push it into the right on 10. Then after we have to push the data 1 and 10 means the 1 is the leftmost of third one and 10 is already existed, so we have to leave it. Then we have to next of function is 8 and 15. Here the 8 and 15 means we consider on the root node. So under the root node, the 8 is a greater, so greater than root node. So we move to the right side. Then after we have to check under the range of 10. So under the range of 10, 8 is less than 10. So it moves under left side and 15 is greater than means it comes under right. So then after we have to push the data as 9 and 15. So 9 is greater than 8. So it comes under right side and 15 is already existed. So it is comes under end. So how it will be based on means based on the next of function, the top of the element should be popped off for entering the data into the stack purpose. So this is the one of the thing for using the iterator in binary traversal. So the same thing we have to use in order iteration and post order iteration. So in order iteration means left root right. So based on the traversal, it will be happen under iterative manner.